Alright, hello. Whew. You guys do not understand what I just had to go through. Well, speeding at sea, it's me, Z. Basically, the chat was not showing. It was showing for my goodbye stream. And well, now everything is lovely once again. How is everybody doing today? Class, it's time for attendance. Hello, Space Guy Rai. Hello, PogChamp Senpai. Hello, Ricardo Berrigan. We will be using Python today, which is the coding language that I'm more familiar with. Hello, Aegis Slayer. How is everybody doing today? How about everybody rates their day from a scale of smiley face to like neutral face to sad face? I am personally feeling maybe like in between a smiley face and a neutral face. But I'm definitely a smiley face right now as we are going to be coding together. I'm so hyped. I'm so excited. I guess another reason why I'm not a full smiley face right now is this is my second to last stream. And this past week I've been preparing my sort of goodbye stream slides and announcements and stuff like that. And I'm so excited to share you guys the announcements. But on the other hand, I'm also just really sad about being off live streams for a while. I'm really gonna miss you, Orbeez. Oh, I'm so glad that everybody has a lot of smiley faces. Um, Took day off tomorrow. Oh, nice. Yeah, no, I am also taking my day off tomorrow. There is a cafe that I especially enjoy, and since I'm traveling, it'll be the last time I'll be able to visit that cafe in a really long time. So I'm going to get my little matcha and coffee, and I will be very happy. Hello, Ducky Tomahawk. Um, I think you're a new Orbeez. Welcome. Um, a lot of people saw my Reddit post this morning where I basically shared some of my astrophotography that I was really excited to post about. And it seemed like a lot of people liked it. I'm just really glad that everybody just has a shared passion and interest for space. All right, let me pull up the writing music. Do you guys hear the music in the background? I hope it's not too loud. Okay, well, let's get started. For those of you guys who may be new, last time we went over the linear regression course, and we finished going through the entirety of linear regression. Now we're going to go through the programming exercise, which apparently takes 10 minutes. So if we have some extra time, we can go through the logistic regression. Where was it posted? Do you mean the course link? There should be a tagged comment or message in the chat that you guys can click. And one really good thing is that this is a Google course and they're using this thing called Google Colab. And this means that you don't need to have any other outside features. I ran some of the lines in advance just to make sure that everything was good, but I haven't even looked at this at all, so we will be going through this together. Space Guy Rai, yes, if you go to r/virtual YouTubers, it should be somewhere in there. Got like a few hundred updates, which was super surprising. I checked it later today and I was really caught off guard. And there was another VTuber in there who had some really great photos of the Milky Way. It was super duper epic. I'm so excited to share more astrophotography with you guys, and even when I'm gone during my break, I'll keep sending those. Okay, Orbeez, are you all ready to code? Because we're gonna get started. Let's take a quick look. Copyright, oh, okay, that's not actual code, that's just copyright. Okay, linear regression. In this collab, you will use a real dataset to train a model to predict the fare of a taxi ride in Chicago, Illinois. Well, knowing the United States, I mean, the taxi ride fare might be a little pricey, but we'll see. We'll see what the model thinks. Ducky Tomahawk, I always miss out on live streams. I looked on your debut, but I normally drive home from work around this time. I can tell you put a lot. Oh my god, wait, that's so sweet. Thank you so much. See, it's messages like these that really just, they really keep me going. Thank you so much. That, you have no idea what that means. That means a lot to me. Yeah, maybe when I return, I can try switching up my schedule. Right now, I just do 7 p.m. PST, but I might try doing a morning stream so that people in like the European or Asian time zones can also visit as well. Oh, hello, Klofne BR. Spent all afternoon trying to get NumPy to give me -0.0 with some friends. Was great. Yes, I mean, we're ready to do a lot more coding. Okay, let's keep reading. After completing this collab, you'll be able to read a CSV file into a pandas data frame, explore a dataset with Python visualization libraries, experiment with different features to build a linear regression model, tune the model's hyperparameters. I just love that word, hyperparameters. Complete training runs using root mean squared error and loss curves. Okay, cool. They have this data set. Okay, setup exercise. Copy this collab. So yes, this is a copy that I've made in my own Google Drive. Load required modules. This exercise depends on several Python libraries to help with data manipulation, machine learning tasks, and data visualization. Run the load dependency code cell below. Oh, I ran this in advance just to make sure that I had all the packages. They're mainly using this thing called haras, which I believe is a combination of, it has something to do with TensorFlow. If somebody in the class knows a lot more about this, please feel free to go ahead. And also to clarify, I am a complete beginner in machine learning, so I'm just really excited to learn with you guys. Okay, load the data set. The following code cell loads a data set and creates a pandas data frame. You can think of a data frame like a spreadsheet with rows and columns. The rows represent individual data examples, and the columns represent the attributes associated with each example. Okay, so this was like the last course that we did. Yay, okay, that ran. So we have the data set loaded. Update the data frame. The following code cell updates the data frame to use only specific columns from the data set. Note that the output shows just a sample of the data set, but there should be enough information for you to identify the features and have an actual look at the data. Okay. Okay, so let's take a look. Updates data frame to use. So I guess we're extracting these specific columns from the huge data set. Oh, wow, this is beautifully formatted. I wonder if this is a feature of Google Colab. No, this is great. Wow, my hand's like bugging out today. What's going on? Trip miles, trip seconds, fare, company, payment type, tip rate. And it has 200 rows. Oh, I wonder what these are. Wow, I think this might be straight from Google Colab. It sort of gives you like recommendations. I don't think we should click these for now though. Okay, part 2, dataset exploration. A large part of most machine learning projects is getting to know your data. In this step, you will use the dataframe.describe method to view descriptive statistics about the dataset and answer some important questions about the data. Run the view datasets code. Oh, that's down here. Code cell. Okay, let's do that first. Let's actually look at the code. So print total number of rows. So it gets the length of the index of the training data frame that we've gotten. And then training df.describe include all. So I guess this receives the data information. Ah, I see. So instead of the actual data, we have like the mean, standard deviation, minimum, 25th, 50th, 75th percentiles, and maximum. Okay, so inspect the output and answer these questions. What is the maximum fare? Well, we go to maximum, and then we go to fare. So the maximum fare was $159.25. Bro, where did this driver go? Did they go to like Mars? $159 is crazy. What is the mean distance across all trips? So mean distance, so trip miles with the mean is 8.3 miles-ish. How many cab companies are in the data set? So do we look at company? I think that's what it's referring to. So we go to company count. So we have, oh, or is it unique companies? It might be unique companies. 31 unique companies and 31,600, I guess there's 31,694 entries. Is that what it's referring to? That would make sense. Orbeez, what do you guys think? I think it might be referring to the unique ones. What is the most frequent payment type? Oh, okay. Top is credit card. Are any features missing data? I mean, these non-values represent missing data, so we don't know the unique fare. We don't know the top fare, or the most frequent fare, or a lot of information about the tip rate either. I think it's unique too. Okay, so I'm not going insane. It wouldn't make much sense if there were 31,694 cab companies. Like, that's just some crazy competition. Okay, run the code, view answer. Oh, run the code, view answers. Oh, okay, cool. So we had 31, we have 8.3. Yeah. Wait, are any of the features missing data? The answer to that was no. Why is that the case? Here. Are any of the features missing data? I thought this non-value was... Oh, maybe... I see. Maybe what we were supposed to look at was the count. And the count is 31,694 across the entire row. So that means that we have data for all of these features all across the data set. And these non-values just mean that maybe it's not applicable. Like, it wouldn't make sense for us to have the most frequent fare. Maybe all of the fares are different so that we can't actually describe the most frequent fare. And we can't describe the most frequent trip seconds because all of them are different. I think that's sort of what it's getting at. Okay, cool. Descriptive statistics can't parse some of the data sets for that attribute. Yeah, I think that's what it means. Like, it wouldn't make sense for us to have a unique trip length because all of them are different. Yep, that makes sense. Okay. Generate a correlation matrix. Okay. An important part of machine learning is determining which features correlate with the label. Okay, so from last course, there were like features, and they help us predict the label, which is the attribute that we want to predict. If you have ever taken a taxi ride before, your experience is probably telling you that the fare is typically associated with different distance traveled and the duration of the trip. Yep, but is there a way for you to learn more about how well these features correlate to the fare? In this step, you'll use a correlation matrix to identify features whose values correlate well with the label. Correlation values have the following meanings. Okay, so 1 means perfect positive correlation. So that's like a direct relationship. When one attribute rises, the other attribute rises. So -1 is like sort of like a negative slope. When one attribute rises, the other attribute falls. And then 0 is no correlation. And I guess you can do like values like in between that can sort of describe how strong that relationship between a feature and a value is. You can't take a standard deviation of a categorical variable. Yep, that makes sense. That makes sense. Okay, in general, the higher the absolute value of a correlation value, the greater its predictive power. Oh, that's an interesting way of interpreting that. Okay, let's inspect the code in the view correlation matrix code cell. Okay, what is this doing? Okay, so it takes the data frame and it does .core. So compute the pairwise correlation of columns. So it goes through every column and determines what its correlation is with each other. And I think what this is saying is we are only looking at the numerical features, because I mean, like CLOF NIHBR suggested you need an easier username. Then we would be able to determine, I mean, if it's categorical, we wouldn't be able to determine a correlation matrix. Oh, hi-fi, data frames. Oh no, I promise this is going to be very beginner friendly. I am very new to machine learning. Also, for those of you who do not know, Phi is an amazing science VTuber. He makes really great content on like viruses, diseases, biology, all of this stuff that was totally my kryptonite in school. So please subscribe to him. He's very epic. Chemistry VTuber when? Oh, well, Phi does viruses and stuff like that. If you haven't already, you should also subscribe to Faye, F-A-Y-E, Faye Drosera. She does biology content. She recently did a video explaining like mitochondria, the powerhouse of the cell, which was super cool. She's also great too. She's been really helping me out, starting out on my VTubing journey. Hey, now I gotta stand by my chemistry inspired. Wait, it's chemistry inspired? What? What does it mean? Oh, wait, is it like Cl, like chlorine, oxygen, F? Just fluorine, I think? And then nickel, hydrogen, bromine? Bromide? Bromium? What's the Br? I'm forgetting. Or is it like barium? No, that's Ba. Well, very epic chemistry username. That reminds me of those like t-shirts that a lot of people used to design like back in high school that had the you can like spell out like really cool things with like the elements. Okay, let's keep on going. Bromia. Oh yeah, I just like cackled just now. Nah, bro. Bro, yeah, no. Yeah, no, bro. I'm cooking those chemical elements. Bromium. I love that. That they should make that a real element. If they find like a whole new row of the periodic table. We are going on such a tangent right now, but PBS Spacetime, which is like one of my favorite YouTube channels of all time, just made a new video on like discovering new elements in the periodic table. I have not watched it yet, but that might be cool to check out. Okay, back on task. Okay, let's run the view correlation matrix cell and inspect the output. So you basically correlate each of these to each other. Well, obviously, like, if you correlate one thing to the same, to itself, then it'll be 1. But trip miles is correlated to trip seconds like this. So it has, like, a positive relationship, but it's stronger for the fair with trip miles. And then there is a 0 is no correlation. So this is actually a very low. So trip miles and tip rate is actually low. That's interesting. I thought that would be much stronger. I don't know about you guys, but I feel like I tip more when the trip is longer, or if it's like more traffic-y. Maybe not in Chicago. Who knows? All right, check your understanding by answering these questions. Which features most strongly correlate to the label fair? So let's look at fair. Well, definitely itself. I mean, it's like perfect, but besides itself, trip miles is 0.975, which is the highest. Oh, wait a second. No, this might be a trick question because we're trying to find the value that's closest to 1. Oh, wait, this is closest to 0. No, so this should be right. This is closest to 1. I think it could have been a trick question if they had a value that was like very close to -1. Which feature correlates least strongly? That would be this tip rate one because it's very close to 0. Okay, let's see if we were right. So the strongest correlation, other than itself, is trip miles. So as you might expect, trip miles looks like a good feature to start with to train your model. Also notice that the feature trip seconds has a strong correlation with fair too. Yep. The feature with the weakest correlation is tip rate. Yep, okay, that's correct. Some packages will apply heat map shading, dark blue to dark red for -1 to 1. That's actually a really cool way to visualize that. I think that makes sense. We love those divergent color maps. All right, visualize relationships in dataset. Sometimes it is helpful to visualize relationships between features in a dataset. One way to do this is with a pair plot. A pair plot generates a grid of pairwise plots to visualize the relationship of each feature with all other features all in one place. So we are using, so SNS is for the Seaborn package. We're using the, we're importing the data frame, the X and Y variables that we want. Let's see what this looks like. Ooh, my hand is bugging out. Whoa! Whoa, 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 whoa. Okay, this is interesting. So on the diagonal, oh, that's really weird. What's sort of showing for these graphs on the diagonal? Okay. Well, I think what's interesting is we said that fare and trip miles are closely correlated. So it looks very much so linear. You can see sort of a linear shape emerge. For trip miles and trip seconds, it's sort of like a fan shape. I guess maybe I think what's being shown on the diagonal is a histogram of the data. So the y-axis would actually be the frequency instead of just the fare. Yeah, it's probably better to show only 1/2. Yeah, this looks really complicated, but I think it basically represents the relationship between each of the data. Okay, now we're getting to the fun part. Well, the previous part was also fun too. Train model. Define functions to view model information. To help visualize the results of each training run, you will generate 2 plots at the end of each experiment. A scatter plot of the features versus the label with a line showing the output of the trained model, a loss curve. Okay, so these are the topics that we addressed in the last class. For this exercise, the plotting functions are provided for you. Unless you are interested, it is not important for you to understand how these plotting functions work. Okay, let's see. Oh, wow. I mean, we can take a brief look. So I guess it's sort of it's making subplots for the loss curve and model plot. Oh, so these are so this is a function that sort of takes the data set and makes these plots. And there's also a loss curve. Okay. It makes, wow, so there's a lot of code here. Okay, so it's also like scaling these properly and making them look really aesthetic. Okay, wait, I want to see what these look like. So let me first run these. Oh, okay, so we just define these first. So the code you need to build and train your model is in the defined ML functions code cell. So let's just quickly take a look. So now we're using the haras package. So that is what we've been using for that, like, it's correlated somehow with like TensorFlow and sort of machine learning stuff. Again, if anybody knows like more details or can give a better summary than I just did, that would be great. So most simple haras models are sequential. So describe the topography of the model. The topography of a single linear regression model is a single node in a single layer. Okay. So it adds the different features. And then we compile the model topography into code that haras can efficiently execute. Configure training to minimize the model's mean squared error. So like we discussed in last class, we're basically working to reduce the mean squared error. So this is the building the model part. And then we train the model. We get the weights and biases. The list of epochs is stored separately from the rest of history. We isolate the error of each epoch. And we take a snapshot of the root mean squared error, which helps us determine how we're going with the training. So we're trying to minimize that. Okay, and then this is basically where we run that in a loop so that we can train the model. So yeah, I'm just gonna run this. Also, if you guys want to take a closer look, if you go into the pinned message, you can load up this Google Colab notebook and also scroll through however you'd like. Okay, train a model with one feature. In this step, you will train a model to predict the cost of a fare using a single feature. Earlier, you saw that trip miles correlates most strongly with the fare. Okay, yes. So let's start with trip miles as the feature for your first starting run. Run the experiment 1 code cell to build your model with one feature. Whoa. Whoa, whoa, whoa. Oh, Interesting. So it's going through the epoch. So this is exactly what we saw being explained in words, not with code. And it's determining the loss. It seems like the loss is not necessarily decreasing at every step, but overall it is. I mean, went from like 262, now it's down to like 13. Oh, whoa. So wait for feature. So this describes sort of the line of best fit through the data. Oh, that's pretty good. And the fair, oh, and then it puts it into this format so it's easier for us to read. And this loss curve, as the epochs continue, we are basically decreasing it, and it sort of forms this like L shape, L for loss, that we saw before. And this looks like a pretty good line of best fit. So let's see if they have any questions so that it's not just like a black box. Review the output from the training run. Okay, so we just did that. Check your understanding. How many epochs did it take to converge on the final model? Well, we went through all 20 epochs. Is there a specific point that we can pinpoint as the finish time? You should see the root mean squared error in the output. Yeah, you can use the root mean squared error to determine how far off on average the predicted fares are in dollars from the observed values. That makes sense. How many epochs did it take to converge on the final model? I mean, I would just guess 20 because that's how many epochs are here, and it seems like it's sort of asymptotically is approaching that. How well does the model fit the sample data? I mean, pretty well. I don't know if they want a specific answer, so let's run these answers. There was a local minima. Oh, okay. Wait, let me go through the chat. Element guy. Are we splitting into the test and train sets? I think we're using the, we're using the entire data set as our training set. Actually, did they specify how much data we're going through? We're going through 630, I think we're going through 634 data for each epoch. I can't recall. I don't think that's the full data set, or is that just a batch? I'm asking this because during the course, we learned about like mini batch training and like stochastic training, where we decided to look at either one or like the entire or like a part of the data set for each epoch, but I think we're going through basically all of it. And hello, Data HSAT-san. There was a local minima in the mid-teens. Local minima in the mid-teens. Let's take a look here. Oh, maybe I should be looking at the root mean squared error. What does this plot? Yeah, the root mean squared error. But I think these are correlated, so we can look at either one. Yeah. The lowest value that I can see, at least visually, is this one, which was about epoch 13. Here, let's see what they mean by that. Special elements. Okay, I'll call you, I can call you special element guy. Use the loss curve. So with this, it takes about 5 epochs? How do they get that? Use the loss curve to see where the loss begins to level off during training. Oh, I see. So you can, so 5 is like right here. So we can, they say that it's about epoch 5 because that's when it starts to like flatten out. I wonder if there's a more reliable metric of doing that than just being like, oh, it sort of looks like it converges. Yeah, it appears in the model plot that the model fits the sample data very well. Okay, cool. Okay, let's experiment with hyperparameters. It is common with machine learning to run multiple experiments to find the best set of hyperparameters to train your model. In this step, try varying the hyperparameters one by one with this set of experiments. Okay. Experiment 1. Oh. Okay. Increase the learning rate to 1. Okay. Update the... Oh, so we update them in here. Okay, so let's see. Update the hyperparameter values in the experiment 2 code cell according to the experiment. What? Repeat for each hyperparameter experiment. Oh, that's so confusing. So we just go through each of these and apply them. Just because it's called experiment 2 doesn't mean we're just doing experiment 2. Okay, so let's first try changing the learning rate to 1. And then let's run the code cell. Huh? Oh, it should be a float. Okay, I think that should be fine. Okay, let's go through this. So now it's running the thing again. After the training run, examine the output and note any differences you see in the loss curve or the model output. So we can compare it to this plot up here. Do-do-do, do-do-do. What do you guys usually do while waiting for code? I've actually been learning a new language. Which may be a bit of a spoiler as to where I will be traveling very soon. Oh, that's horrendous. Yeah, no, this does not converge at all. So just like we talked in the last course, because the learning rate is too large, it just keeps bouncing between different possible values for the bias and the weight, meaning that it never actually converges to a correct answer. I mean, this doesn't look horrible, but it's not quite the right fit. Okay. Let's try, let's try decreasing the learning rate to 0.0001. Batch size at 50. Okay. Emails? Yeah, no, I also have the tendency to check Slack. Actually, the best decision I've made is to uninstall Slack from my phone. There was a period where this is so embarrassing, I was addicted to Slack. I had it on my phone, I had it on my iPad, and every moment I would be checking it. And even if there was nothing, it was not good for my health. Oh, this is not good at all. Oh, so what happens here is that our learning rate is way too slow, so it won't converge to the correct location. Or the correct weight and bias. So, yeah. I mean, that's pretty cool. Pretty cool to see that. Okay. So now we reset the learning rate to 0.001 for experiment 3, and then increase the batch size to 500. Space car, the worst kept travel destination. I know. I've been giving a little too many spoilers. Oh, did I not run that properly? Oh, whoa, that was just really fast. Wow, that was super fast, but the loss is really off. What happened? So when we increase the batch size to 500, it seems like the loss is still huge. And this doesn't look like a good fit at all. Maybe it's because we set the batch size so large that it's being affected by like this outlier here. Maybe that's why it's off. I thought increasing the batch size would actually improve our training results. That's really odd. Okay, well, we can answer these questions now. How did raising the learning rate impact your ability to train the model? Well, when we set it too high, it just kept bouncing around, it didn't converge. And when we lowered the learning rate, it was too small, so the steps were too small, and it also didn't converge. And then when we changed the batch size, it gave us an incorrect result. Maybe because of the outliers? So double click to view the answers. Let's see what they say. When the learning rate is too high, the loss curve bounces around and does not appear to be moving towards convergence with each iteration. Yep. When the learning rate is too small, it may take longer for the loss curve to converge. Yep. With a small learning rate, you can increase the number of epochs so that your model will eventually converge, but it will take longer. Okay, let's take a look at this. Increasing the batch size makes each epoch run faster, but as with the smaller learning rate. Ah, I see. The model does not converge, so it's not because of the outliers. It's because when we increase the batch size, it we're going through each epoch faster. But we don't have a large enough learning rate to deal with that. So if you have time, try increase the number of epochs, and eventually you should see the model converge. So let's say we have 50 epochs now. I don't know if that will make a huge difference. Yeah, no, each epoch goes by super fast. That's why I didn't even notice it went by. That's like me and Reddit. Oh, yeah, no, this is starting to converge. Oh, and this is a great fit. So when we increase the batch size, we also need to be conscious of how many epochs we have. I only use Slack for work. The sound notification is trauma. No, the sound notification is trauma. Yeah. But sometimes I like checking Slack for like the memes. Because some of the Slacks I have like channels dedicated for like memes or pets. It's super fun. Okay, train a model with 2 features. The model you train with the feature total miles demonstrates fairly strong predictive power, but is it possible for us to do better? In this step, try training the model with 2 features, trip miles and trip minutes, to see if you can improve the model. Okay, so now with 2 features. You may recall that the original data does not include a feature trip miles, but you can do that with trip seconds. Okay, cool. Review the code in the experiment 3 code cell. So this is the same as before. But now we have trip minutes, which we get by dividing trip seconds by 60. We have our features that we're trying to use, which are trip miles and trip minutes this time, and fair. And we can run the experiment with these features. Okay, now we can run the code cell. Okay, let's see what we get. Oof, I need a bit of a water break. Reminder for all the Orbeez to stay hydrated. I don't know why I just like showed my water bottle to the camera, like fully anticipating that it would show up. Whenever I drink water, my hand throws like crazy gang signs. Oh, whoa, whoa, whoa. Whoa! Oh, I love this 3D plot. That looks epic. Okay, so we got the weights and the bias. So the bias is like the plus B term. And then and then we have the weights, which are sort of the slope. So loss curve definitely converged. I wonder if there's a... Wait, that's so cool. Wait. Wait. Oh, wait. No, wrong plot. Oh, wait. Oh, no. I want to zoom into this one. Oh, sheesh. Oh, sheesh. That is Are you guys seeing this? Orbeez, isn't this the coolest thing ever? Oh, sheesh. Bro. This is crazy. This is revolutionary. MATLAB can't... Honestly, most things can't even compete with that. That is slick. Okay, I've like really just like adjusted this a little too much. But, oh, so this is like the loss curve thing, I think? Or... No, this is just a 3D graph representing trip minutes, trip miles, and then the fare. Wow, that's slick. Google's really flexing on us. Does it make a difference if you use trip sec... Oh, wait, hold up. Does the model with 2 features produce better results than using 1 feature? I mean, we have this, which seems... I mean, it seems to be doing pretty good. Because, you can... I mean, it seems to be fitting pretty well. I can't say much about it being better. I mean, it does converge faster. So... maybe that would be true. So maybe that would be true. Does it make a difference if you use trip seconds? Oh, what? Oh, oops. Sorry. There we go. Does it make a difference if you use trip seconds instead of trip minutes? I mean, I don't think it would. It would just change the scaling because the values are still the same. The data set is still the same. How well do you think the model comes to the ground truth fare calculation for Chicago taxi trips? Okay, notice that the scatter plot of the feature versus the label is a 3-dimensional plot. Okay, that's great. That's slick. With 3D model, if the train model is good, you would expect most of the examples to land on the plane. Wow. Okay. How well do you think the model comes to the ground truth fare calculation for Chicago taxi trips? I mean, I feel like it would be constrained better. I mean, like, look at all those dots on that plane. You know Z's for real when they're geeking out over a 3D graph. Honestly, this makes me the happiest person in the world. Think you'd like Wolfram Alpha? Yes, I've actually played around a lot with Wolfram Alpha. I actually got the chance to meet Stephen Wolfram himself. That may be reserved for another story time. Okay, well, I can explain it briefly now. I basically met him. I freaked out. I was barely able to put cohesive sentences together. Some people were asking for like autographs, but I was just so in shock. I just like froze. I like could not move. Yeah. I met his daughter too, she's super sweet. Minutes versus seconds might have an impact because you want your variables to be the same order of magnitude. Ah, I see. So trip miles is like roughly like in the tens, and so is trip minutes. Yeah, but I think like it won't change like the fitting, but it would definitely change the axes. Mr. Wolfram. Yeah, no, that was so epic. It was very epic. That was probably, I still remember that day very, very clearly. All right, let's look at the answers for training with 2 features. Oh my god, Google Colab is like a serious yapper. No, I'm just joking. This is great. To answer this question, compare the RMSE for the root mean squared error for each model. For example, the root mean squared error for the model trained with 1 feature was 3.74, and the root mean squared model for the feature with 2 features is 3.4787. Oh, so you actually have to check what the final root mean squared error is. I mean, it was 3.4, which I think was lower than last time. Uh-oh. Makes predictions that are about 0.27 closer to the observed fare. Ah, that's smart. Oh, so you can really just take the difference and say, okay, it makes this much sense, or dollars and cents, closer to the observed fare, so it turns into physical units. When training a model with more than 1 feature, it is important that all numerical values are roughly on the same scale. In this case, trip seconds and trip miles do not meet this criteria. Ah, I see. Ah, then, I think Jeep and, Special Elements guy were right. The mean value, that's 2 orders of magnitude difference. Converting the trip duration to minutes helps during training because it puts values for both features on a more comparable scale. So you can't just do it just because it's like the same data set. You actually have to be conscious about the scale. That's actually really cool. Of course, this is not the only way to scale values before training, but you will learn about that in another module. In reality, Chicago taxi cabs use a documented formula. Oh, so that's why they're so closely correlated, because they actually use a formula. Typically, you would not know the correct formula, but with this model training, we would be able to. It's pretty cool. That's actually really interesting. So we can basically just like take a bunch of data and find the line of best fit. That reminds me of like back in the olden days, like for like calculus or whatever, like you would take your little calculator, like put in the data and they would like draw a line of best fit. It's basically doing that, but now we're actually doing it in code and doing it by ourselves. Okay, use the model to make predictions. Now that you have a trained model, you can use the model to make predictions. In practice, you should make predictions on examples that are not used during training. However, for this exercise, you will work with a subset of the same training data set. Okay, run the define functions to make predictions code cell. Okay, run the make predictions code cell. Okay, whoa. Oh, wow. Okay, so what is this showing? We take the predicted fare, observed fare. Oh, okay, so we predict what the fare would be. We compare it to what the observed fare actually was. We compare the loss, I think, yeah, they just subtracted the 2. And these are the features that we put in. Okay, we just did that. We reviewed the prediction, the output. How close is the predicted value to the label value? In other words, does your model accurately predict the fare for a taxi ride? Well, if we look at the loss, I mean, it's off by a few cents. I mean, in some cases, like, it's off by, like, a few dollars, but I feel like it's pretty good. I mean, it's not exact, but I'd say, like, starting from scratch and being able to predict this, it's pretty good. I feel like, this, like, $2.65 difference usually happens when the fare is larger. Like, for example, here, we have an observed fare of like $47. In that case, a loss of $2 was probably seen as like less important. Whereas if you had like a fare that was like $5, then like if you had a difference of $2, that would make a pretty big difference. That would literally be half of the total cost. Okay, let's see what the answer is. Okay, yeah, based on the random sampling of examples, the model seems to do pretty well. Most of the predicted values do not vary significantly from the observed value. You should be able to see this by looking at the column L1 loss is equal to observed minus predicted. Cool. Well, that was the entire notebook. I feel like this was structured really well in a way that was like really easy and intuitive. Though I'm a little sad that there wasn't actual coding. Like, I really wanted to like get my hands wet and like, you know, clickety-clack on the laptop. But I think we'll have many opportunities to do that in the future. I mean, for the Orbeez who are here during episode 1, I mean, the main goal is to create a surreal meme factory, which could generate, like, the image of the meme and the caption. I think it would be good to start with the caption. But, yeah, that would be super epic. And we will definitely get into a lot of coding then. To be fair, today, I did a lot of coding personally as well. So maybe this is a sign to just sit back, relax, and just learn. Well, that was the entirety of the linear regression section. So I think we have a little bit of time. How about we tackle the logistic regression section? What do you guys think? Pretty good in my opinion, right? I mean, it says it's 35 minutes, so, and there's no programming exercise, so we'll just be learning. What they don't tell you in data engineering school is that 99%. Honestly, what they might not tell you in, like, coding school is that 99% of the time is, like, debugging. You know what they always say? It's like, the thing that takes 10%, the thing that you expect will be 10% of your project takes 90% of the time. And the thing that takes 90% of your project actually only takes 10% of the time. Things always go longer than you'd expect. So, well, since we have time, and also since this is the last machine learning stream before my break, let's cover logistic regression. And also, don't worry, I will definitely pick this up when I return. This is super cool. I feel like this course is organized really well. Okay, let's look at this. Learning objectives. Identify use cases for performing logistic regression. Explain how logistic regression models use the sIgMoId function. That kind of sounds like the Sigma function. This, you know what might be a good surreal meme? It's like a, you know about like Sigma males? Like that's like a whole like meme genre. You can have like sIgMoId functions. Oh yeah, I identify as the sIgMoId function. To calculate probability. Compare linear regression, logistic regression. Explain why logistic regression uses log loss instead of squared loss. Explain the importance of regularization when training logistic regression models. And we covered these. And if you haven't already, please be sure to check out episode 1. Oh, there's a video here. In the linear regression model, you explore how to construct a model to make continuous numerical predictions, such as the fuel efficiency of a car. But what if you want to build a model to answer questions like, will it rain today, or is this email spam? Ah, okay. So this module introduces a new type of regression model called logistic regression that is designed to predict the probability of a given outcome. Okay. And again, I won't actually be playing these videos because I don't want to get copy striked. But here, let me actually repin this message. So follow along with logistic regression, and you guys can follow along with this course. Oop, how do I pin? Okay, cool. And this also means if you'd like, you can go through the videos in your own time. I did get the chance to watch one of the other videos, and it was explained really well. So I really recommend you guys check it out. Sure, it gets easier to predict, but there are always outliers. I can't believe that's a real function name. If I were to reincarnate as a function, I would want to reincarnate as the sIgMoId function. Actually, I think being a sine function would be super epic. Oh no. I think maybe I really like the tangent function. Like, think about those, like, tall, slender figure. Yes. Reminder to drink water. Calculating a probability with the sIgMoId function. I'm so excited. Many problems require a probability estimate as an output. Logistic regression is an extremely efficient mechanism for calculating probabilities. Practically speaking, you can use the return probability in either the two following ways. Applied as is. For example, if a spam prediction model takes an email as input and outputs a value of 93.2, this implies a probability, that the email is spam. Or you can have it as a binary category as true or false, spam or not spam. Okay. So this focuses on using the model output as is. So it takes, like, it gives a probability. Oh, and then in the classification module, which I think is the next one, you'll learn how to convert this output into a binary category. Okay, let's check out the sIgMoId function. Zeku, hello. Wait, Zeku, you were the one who commented on the Reddit page with the really gorgeous picture of the Milky Way. Well, hello, it's so great to see you in class. Now let's see the sIgMoId function's business card. That reminds me of the, what's it called, that one movie? American Psycho, where they're, like, comparing the business cards and there's, like, literally, like, a tiny difference between them. Yeah, no, Zeku, I posted something on Reddit today with my astrophotography, and Zeku commented with, like, the most gorgeous image of the Milky Way. With a DSLR camera, by the way, not even a telescope, which is crazy. Trig function tier list when. Maybe I should do that. I already did Smash or Pass Nebula Galaxies. Maybe the next one is trig functions. Who knows? Maybe I should jot that down. Oh my god. Rule number 1 of being a physicist. Always have a pen on hand. Ah! Okay, nothing happened. Nothing happened. Just me trying to search for a pen. Okay, I don't have a pen, which means that I'll just have to refer to, like, carving it into the paper like a Mesopotamian, like, clay tablet. Wait, this is so sad. I have, like, a pen that I usually leave here. Where did it go? Okay, we ball. Okay, let's just keep on going. I'll remember it. I'll remember my brain. Who needs pencil and paper when I can just store everything in the brain? Okay, let's go on. sIgMoId function. You might be wondering how logistic regression model can ensure its output represents a probability. See, you have a computer, use the notepad. I mean, I could do that. Hold up. I also have a notepad on my phone. Let me say trig function tier list. Once I was in a DiffyQ class when the professor asked a student for his favorite function. Despite all study, he froze up at the question. No, if someone asked me what my favorite function would be, I'd probably say sine or tangent. DiffyQ though, that was a pretty cool class. It was a pretty cool class. But I hated it when the professors would just drop like the most crazy integrals on the exam, and then the exam would not even be about like what you learned. It would just be like who can finish the most integrals the quickest, which was like kind of frustrating. But I mean, as an integral Olympiad individual, no, I'm just joking. But I do like solving integrals. Maybe I should just do a cozy stream where we solve integrals together. I'm writing this down too. Integral solving stream. I'll have like lo-fi in the background. Oh hell no. I use sticky notes constantly while Like, I burned through a Post-it pack, like, so quickly. But I need to find my pen later. Would you guys be down for that? An integral stream? Because I totally would. Okay, let's keep on going. You might be wondering how logistic regression model can ensure its output represents a probability, always outputting a value between 0 and 1. As it happens, there's a family of functions called logistic functions whose output has those same characteristics. The standard logistic function, also known as the sigmoid function. Sigmoid means S-shaped, okay. Has the formula, f of x is equal to 1 over 1 plus e to the negative x. Okay, so that's definitely between 0 and 1. The curve approaches 0 as, okay, that's pretty cool. As the input x increases, the output approaches but never reaches 1. As the input decreases, the sigmoid function's output approaches but never reaches 0. Okay, let's actually see this. The table below, oh, whoa. Transforming linear output, whoa. So we have the linear, so this is similar to the linear equation we used before. With z, it's me. Z is the output of the linear equation, also called the log odds. B is the bias, W is the learned weights, X is the future values for a particular example. Oh, and then you pass the Z value, you just put it straight into the sigmoid function. You pass me into the sigmoid function, that's pretty epic. I want to be passed into the sigmoid function. Oh, and then it converts it so that it stays between 0 and 1. Oh, wait, what? We just looked into this. Okay, so, yeah, so we take the output of the linear equation and we shove it into the logistic regression equation, the sigmoid function, so that it gets between 0 and 1. Okay, so this kind of shows the same thing. We have a linear equation, and then it sort of plots out to this one here on the right. Cool. In figure 2, a linear equation becomes input to the sigmoid function, which bends a straight line to an S shape. Okay, cool. Notice that the linear equation can output very big or small values of z. But the output of the sigmoid function y prime is always between 0 and 1. That makes sense because it's a probability. For example, the orange rectangle on the left graph has a z value of -10, but on the sigmoid function, it's like 0.00004. Okay, cool. So a logistic regression model with 3 features has the following weights and biases. Given the following inputs, what is the value of z for these input values? Okay, so we need to go back to this equation. Z is equal to b plus w1x1 plus w2x2 plus blah, blah, blah. Okay, so z is equal to, okay, this would be, okay, I'm just gonna jot this down real quick. I have my little iPad here. Okay, so we have z is equal to w1x1 plus w2x2 plus w3x3 plus the bias, b. So that means we have 2 times 0 is 0, -1 times 10 is -10, plus w3 times x3 so is 10, and then we have the bias as 1. So that gives us 1. So the value of z is just 1. Okay, correct, the linear equation. Okay, we just did that. What is the logistic regression prediction for these output values? So we had this expression above. So we use y prime is equal to 1 over 1 plus e to the -z. But we said z is equal to 1. So we said 1 over 1 plus e to the -1. Oh, you've got to be kidding me. I can't do that in my head. Okay. This just means I gotta get out my, they're really making me pull out all my gear. My handy dandy calculator. So, oh my god, it needs to restart. So I have a TI Inspire, which is basically like a computer type calculator. It's super nice. It has like a keyboard, has like a number pad. It's super great. In the meantime, let me read the chat. When I took DPQ, the professor was too smart to teach undergrads. He went to a TA, he ironically said it was a skill. No. I feel like there are some professors who I feel like they're like so when professors teach undergraduate classes, like it's really good to be conscious of like sort of all the undergrads come from like different levels in like high school or different experiences in their classes. And so I feel like the best teachers that I've had are the ones who really spend the first week like catching everybody up to speed and then going really deep into the content. I don't know if you guys have had really bad experiences with physics teachers. Okay, let me type this into my calculator. E to the -1. So that gives me 0.731. So that's logistic regression for these input values. Yep. Wow, they really made me get on my calculator and everything. Okay, cool. Let's do loss and regularization. Logistic regression models are trained using the same process as linear regression models, with two key distinctions. Logistic regression models use log loss as the loss function instead of squared loss. Applying regularization is critical to prevent overfitting. Okay, so this regularization thing is a new thing. So is log loss. Okay, so let's take a look. Intro physics and chemistry in my undergrad were run by people who did research on teaching. Research on teaching? Oh, so they like figured out the best ways to teach people. That's actually great. What's amazing? Biology was a nightmare of a department. I feel like every college sort of has its like ups and downs with different fields. Unfortunately, I've heard of a lot of people who've like given up on physics because they had like a really bad physics teacher, like whether it was like when they were getting started in like high school or someone they encountered in undergrad. And it's like these teachers really make a big difference in how you think about the field or sort of how you associate physics moving forward. I don't know, one of my personal goals is to definitely be to learn how to explain concepts in a way that's accessible and be a good teacher to others, because I feel like I've received a lot of amazing teaching and it would be really great to sort of like reciprocate that help that I've gotten in the past. Keep the new generation of physics enthusiasts going. Okay, let's keep going. In the linear regression model, you use squared loss, also called L2 loss, as a loss function. Squared loss works well for a linear model where the rate of change of the output values is constant. Okay, so in this case, we had the linear model. However, the rate of change of a logistic function is not constant. Okay, yes, because it's like S-shaped instead of linear. When the log odds z value is closer to 0, small increases in z, small increases in me, results in much larger changes of y than when z is a large positive or negative number. Oh, because it's S-shaped. Okay, so if we have an input of 5, so that varies the precision required to capture differences in the results. Ah, I see. So that's why we need to do log loss, which is different. So if you use squared loss, you would need more memory to preserve the precision because the zeros would literally increase and it would be like 0.0000000 or whatever. Yeah. Instead, the log loss function for logistic regression is log loss. The log loss equation returns a logarithm of the magnitude of the change, rather than just the distance from data to prediction. Okay, so we do the sum across the data set, so that's what this represents, which are xy pairs. Y is the label in a labeled example. Since this is logistic regression, every value of y must either be 0 or 1. Okay. So y prime is your model's prediction, which is guaranteed to be between 0 and 1, given the set of features in X. So we have this crazy expression. Okay, regularization. A mechanism for penalizing model complexity during training is extremely important. Oh, so it makes sure that we're not expending so many computational resources. Without regularization, the asymptotic nature of logistic regression would keep driving loss towards 0 in a case where the model has a large number of features. Consequently, most logistic regression models use one of the two strategies to decrease model complexity. L2 regularization or early stopping. Here, I'm going to try to open these. Limiting the number of training steps to halt training while the loss is still decreasing. Oh, wow. Wait, is this next on the course? Oh, no, it's just a separate window for us to open. So we used L2 regularization. I'm just curious to see, like, what the general summary is about. I guess it just is. Where is this relative to the... I guess it's just a separate window. Wow, they didn't actually include this in the course. For example, the following table shows a calculation of L2 regularization for a model with 6 weights. So notice that the weights close to 0 don't affect L2 regularization much, but large weights can have a huge impact. A single weight contributes about 93% of the total complexity. I see. So basically this is sort of a way for us to push weights toward 0. I see. Oh, that's because the squared value of weight 3 is 25, which is such a huge total of the L2 regularization. So 25 is 93% of 26.83. So you actually need to decrease this one a lot. So I guess it sort of monitors that. So we would expect the overall complexity to drop. Yeah, because it would encourage the weights towards 0. So that's sort of how it works. If you use L2 regularization while training a model, some features will be removed. I mean, I don't think anything will be completely removed, but I feel like I could see a weight being dropped to the point that it's like basically has no influence so that the complexity would be 0. But I feel like it wouldn't be removed. Yeah. Never pushes the weights all the way to 0. It would just minimize them so that the complexity would be much lower. Okay. I think that's pretty good for that. Oh, this was the same article. Oh, because I clicked the early stopping link. So early stopping is a regularization method that doesn't involve what? It doesn't involve a calculation of complexity. Instead, it means ending training before the model fully converges. For example, you end training when the loss curve for the validation set starts to increase. Although early stopping usually increases training loss, it can decrease test loss. I see. So training is when we're like building the model, and then testing is when we're testing them. I just used the word in the definition, but that makes sense, I guess. Orbeez, how do you guys feel about this? I feel like this is a little bit more in depth into what this regularization thing, but I'm pretty curious. Early stopping is a quick but rarely optimal form of regularization. The resulting model is very unlikely to be as good as a model trained thoroughly on the ideal regularization rate. Huh. Okay. That's pretty cool. So I guess TLDR is that regularization helps us make sure that we don't expend like infinite computational resources in doing this. Okay, that's pretty cool. Okay, class check. How's everybody feeling about the pace that I'm going at? Is it too fast, too slow? We're already at the test your knowledge section of logistic regression, and we could go into classification, but it seems like this is 70 minutes, and it might be better to save it for next time instead of having to like stop halfway through, if that makes sense. What do you guys think? If you guys want, after we finish logistic regression, we can also chat for a bit. We can do that too. Ozymandias. Oh, hello, by the way. I spent my first 2 years in college majoring in math and physics, but ended up switching majors. What did you decide to switch into? Yeah, no. I feel like that kind of story is way too common. I've also heard of a lot of people who start in physics or decide to switch into like finance because the modeling that they do to model the financial markets is very similar to the ones that you use in like physics statistics. And it makes more money. But it's sort of, you're losing that sort of physics edge. Special elements guy, when you have a potato with a keyboard on top, sometimes you gotta cut computational time. Yeah, when you have a potato. Fortunately, my computer is not much of a potato, considering that it's running literally everything, including my Vtuber model, including the screen, including OBS and YouTube. Actually, every time I stream, I can like feel the laptop like heating up. Hopefully this will get a little bit better now that I'll have a, like a microphone. Maybe that's one less thing for the computer to worry about. Or maybe that'll make things worse. Who knows? All good so far. Brain fried. Ruh-roh. Sounds like a plan? Okay, yes, makes sense. Stopping? Okay, yeah. I don't want to leave you guys on a cliffhanger right before I leave and then be gone. I switched to comp sci because I've been coding for a long time. Oh, that's cool. I feel like there's a lot of intersections between computer science and physics as well. I feel like nowadays there's a lot of CS and physics, for example, but also a lot of intersection between like physics and engineering, like in space or like in aerospace, which is super duper cool. I mean, I do CS stuff for physics, and I feel like I just really like coding in general. And now I'm learning about machine learning, which is great. All right, guys, I think it's time for us to do the quiz. Oh, okay. Oh, ruh-roh, it's another one of these. You need to answer at least 4 questions correctly to pass this quiz. Okay, moment of truth, Orbeez. Let's do this. Why is a linear regressions model output a poor predictor probability? It only has one weight per feature. It only has one output value. The bias parameter skews the output value. Its predictions are not restricted to 0 and 1. Here, let's do a poll. I mean, this might take a while, but I feel like it's good to get everybody's vote. If you're using an angle, getting a laptop, getting an angle stand for it will help it vent hot air. Oh, yeah, no, I definitely want to do that. One day I want to get a standing desk type thing where you could like place the laptop on it. Orbeez, why aren't you doing the poll? I'm watching you. I'm just joking. Well, I don't mean to like bias the results, but I feel like it's kind of because of the predictions are not restricted to values between 0 and 1. Because that's not probability if it's not between 0 and 1. Okay, there we go. Maybe my laptop was just slow. Yeah. We are unsure. It's alright, Orbeez. It's alright. We're all learning. I think it might be D, and I think there's a few votes for D. Okay, let's click this for now. Worst case, we can just redo the test. True or false? A sIgMoId never outputs the value 0 or the value 1. Well, I think it wouldn't be good to do a poll for this because there's 2 options, but I feel like it would have to be true because it asymptotically approaches the value instead of actually going to it. True or false, applied regularization is less important when training logistic regression models than it is for training linear regression models. No, it would be more important because when we go to smaller and smaller values, that's when we're getting the high complexity. We're using a lot of computational resources because we're going to like 0.000000001, which takes up so much more memory. So this is false. Which of the following options matches both linear regression and logistic regression? Okay, let me do another survey. Oop. Start a poll. Q2, A, B, C, D. Okay. Which of the following options matches both linear regression and logistic regression with appropriate loss functions for calculating loss? Well, I think logistic regression definitely has to have log loss. Oh, well, there's really only one option that has that. There's only one option that has that. Okay, yeah, it's C. It's C. Yeah. Which of the following is an effective regularization technique for logistic regression models? Oh, well, I mean, I can just click that because we just read the article on it. It's called early stopping. Okay, Orbeez moment of truth. Dun dun dun. Let's freaking go! Victory Royale! Woohoo! Big W. Big high fives and claps in the chat, y'all. This is crazy. We got a 5 out of 5. We got 100%, an A+, big brain time. Oh. Wait, so, I guess, do I have to, like, refresh this? Oh, I just did that. Okay, great. Let's see. What's next? Okay. The next section is classification, which means we just finished the logistic regression section as well. Class, how is everybody feeling? Feeling like you learned a lot more? Well, even if you want to go back, these VODs will be open for you guys to go back and review, and the course will also be open as well. Okay, so I'm gonna close this real quick. And do you guys just want to do like a general chat for a little bit? Let me end this poll. All right, let's end this poll. I feel a little bittersweet. Like, on one hand, I feel so happy that I felt like the notebook would take a really long time, so I'm really happy that we went through both the notebook and the logistic regression part of the course. But I'm also really sad that we won't be able to pick this up until I come back. And I don't know, I'm feeling a little bittersweet. On one hand, I'm really excited for travels, but on the other hand, I wish I could spend more time. I think also preparing for my goodbye stream tomorrow. I actually had to take the live stream preview down because that was what was affecting my stream elements chat, but it'll be back up after this, I promise. But yeah, I feel like it's been about a month since I started, but the first few weeks are sort of like how the next few weeks are going to be, where I just made videos and I didn't do an actual live stream until the end of July. Aw, PogChamp Senpai, it'll be fine, we'll be here. Oh, that's so sweet. That means a lot, honestly. I'm feeling really worried that I'll come back and, I don't know, people will have moved on to like the next best thing and I'll just be a remnant of the past. Space Guy, I like getting the summer off and coming back and forgetting everything you learned. Yeah, no, I feel that too. I think before I come back, I'll definitely review the VODs. And I'll send reminders for you guys to review the VODs as well. It'll be your little homework. Are you guys doing anything fun for the summer? Hopefully other than working. Hopefully you guys are doing something actually exciting. Yeah. Yeah, no, I've been prepping a lot of really fun announcements for you guys, though, which I'm super duper excited to share. I think that's the one thing that's making me really excited for this stream, because there have been a lot of things that I've been building up to. We'll study the notes. All right, class, that's your homework. That's your homework. And when we come back, there'll be like a reading quiz, so make sure to get your game on. A special elements guy. It's too hot to do things. Oh, yeah, no. Oh, definitely. Global warming really got us there this summer. It's crazy. I've been seeing pictures of like cars melting and that kind of stuff. It's very, very hot. Especially if you're like on the West Coast, near like the center of the US. Swimming mostly. Yeah, no, swimming is epic. I actually haven't done much swimming though this summer. I feel like here's a little fun fact about me. When I was in middle school, I did like a bit of a competitive swimming. I was horrible at it, by the way. I was really bad. But the only stroke that I was actually good at was breaststroke. And I would literally like, I was so bad that like my coach would basically, usually what the coach would do is put you in like a wide variety of events. Like you could do like an IM, which is like basically like all 4 of the strokes, or you could do like freestyle and like butterflies, like separate events and so forth. But I was only good at breaststroke, so my coach only put me in for the breaststroke events. Oh my god. I mean, I kind of slayed in breaststroke, but yeah, overall, I mean, distant memories of the past. But I feel like that little middle school part of me, like the swimming part, is definitely stuck with me. I feel like if I were to choose an exercise that I could do very often, I'd do swimming. Only breaststroke though. You placed? Oh yeah, no, I was pretty dang good at breaststroke. Like I made it like pretty high up. Like I qualified for some like pretty good tournaments too. Although only in breaststroke, which was like a bit funny. But whenever there was like a relay, when you had like multiple teammates basically doing the strokes, so like one person would do like butterfly, or I guess the order is like, I think it was like backstroke, butterfly, breaststroke, freestyle, or something like that. I would be like the designated like breaststroke person, so that was epic. Yeah, nice. Anything you guys have been getting into recently? I have actually been trying to get more into like Pilates. I know that's probably the most like stereotypical like thing to do, but it's actually been really nice. I feel like it's good to be mindful and like, I don't know, be active after sitting at my desk coding, like hunched over like a shrimp, like all day. I feel like sometimes because of that, I am like carbonizing. Like I am evolving into a crab actively as I'm coding. Yeah. Whew. Yeah. I've also been trying to watch the Blaze Star every night. I've been really waiting for it to explode, but I haven't seen anything yet. Honestly, so far, I've just been trying to look at it, and I've been taking photos of it every night, and hopefully I can do like a time lapse. I'll definitely send it to you guys once it's done. Been getting into looking longingly at job listings, hoping for the grass to be greener. Oh, yeah, no, the economy is not doing well. Yeah, no, I feel like that's really... One of my friends applied to, I kid you not, like triple digit number of jobs, and it's just it's like this person that I know is like very, very qualified, like extremely qualified, like they're super smart, but it's just like the industry is just so rough right now. Gonna sound crazy, guys, but I've been getting into machine learning for the past 2 days. Honestly, wait, same. Wait, that's so crazy. That's such a coincidence. That's good for relaxing body mind. Wait, that's so funny. It looks like PodChamp somebody like replied to M. Sean and was like, yeah, machine learning, that's good for the relaxing body and mind. I've been studying for certifications for work. Oh, it's so boring. Oh, that sounds like a big oof. Hopefully these streams make things a little bit more fun. Oh, one thing that I've been really getting into, I have been playing a lot of Cult of the Lamb. They recently released their new update, their new free update on Holy Alliance, and I kid you not, I have like about like 30 hours racked up on my Cult of the Lamb cult, and that's just gonna keep going up. But although I really love the new update, the free version doesn't have like many huge upgrades. And I think since they just rolled it out, it's also been really buggy for me too. Every time I try to open it, it like crashes whenever I'm like in a battle or something. So I think I'm gonna wait until they maybe do another upgrade for it. I feel like usually when they roll out these new updates, there's usually bugs. So yeah. Oh, I've also been making a lot of more surreal memes. So I have a surreal meme account. If you guys probably already know. And there is this company called Studio Cult, and they make really, really weird earrings. Wait, hold up. Let me, I think I may have mentioned this in my Twitter before. Here, let me, this is very nerdy, by the way. Some of these are a little odd, but let me show you. Like, they have this, like, hex key one. It looks really weird. This is very much very odd. But the point that I'm trying to get with this is that I am a nerd, I am an engineer, and I really like these. And so I was just chilling on my surreal meme account, just, like, going through comments and stuff like that. And this exact company actually reposted one of my surreal memes saying it's like surreal meme summer, and I have never been more happy in my entire life. I was so excited. I was like overjoyed. I was like, thank you so much. Hallelujah. The weird nerd company store has praised me from the void. But yeah. That was definitely a highlight, a recent highlight. Oh, I've also been watching like Markiplier's videos on Buckshot Roulette, which is like this like kind of crazy like roulette game. I mean, I'm pretty sure you guys are all familiar. And that has been really consuming my time too. It's super cool. Official sponsorship incoming. I hope, I pray. I mean, my Cereal Meal account is not that big, but I would be happy to do a sponsorship. I would happy to be like an ambassador of their earrings. I just want the hex key one. They also have a star one that looks like a star is going through your ear, which is the most Syzygy coded thing. It must have felt surreal that they did that. No, that as a surreal meme creator, I felt surreal that they did that. What kind of games have you guys been playing recently? I don't know if you guys know about this game called Class of '09. It's like a really sort of messed up visual novel, but I have been like watching the playthroughs of it. It's a little odd, but it's also really funny. It's basically about this like girl who's like in 2009 and sort of her adventures as she traverses high school. I feel like it's just like a really funny, ironic game. But yeah. Whew. Drink some water. Yeah, I might actually wrap up soon. I feel like my voice has been also running a little low, and I need to save my voice for tomorrow. I also need to wake up early so I can visit my favorite cafe for the last time. There's some bad endings in the— yeah, no. Special Elements guy, you are so right. There are a lot of bad things in that game. But I think it's also a little funny. A bit of Pathfinder Wrath of the Righteous. Ooh, I've not heard of that game. That's really interesting. I really should collect like a Google form with like game suggestions. And no, you cannot list Soma. That is in the most requested game. I really want to play Super Hot though. I feel like I love the time stop thing. Alexander Babsky, have you ever met a famous scientist before? I met Harold Crotto of my— oh, that's crazy. Off the top of my head, I met Jocelyn Bell Burnell before. I think I mentioned this before. She's the woman who discovered pulsars. And she didn't get the basically the whole story is that at the time there was a lot of like sexism, and she discovered the pulsar, but it was her male supervisor who got the Nobel Prize, and she didn't get any of it. But in her talk, she said that in exchange for not getting the Nobel Prize, she has gotten basically every other single prize in existence. And I think from what I know, she's just a really kind-hearted person. I think she donated a huge percentage. I'm even thinking maybe all of her prize money to supporting women in science, which was really inspiring. Have you tried Kerbal Space Program? Yes, I have, but I'm not as familiar with it. I actually got it for free during this 1 week where they had like Kerbal Space Program for free, but I want to get more into it again. I'm trying to catch up the newest Final Fantasy expansion. Ooh, I've actually never played that either. See, I didn't have like a gaming childhood growing up, so I feel like I need to make up for it now. I am playing like Subway Surfers and Plants vs. Zombies because, yeah. I've been playing some Stardew Valley too, which has been pretty nice. But yeah, I definitely want to get more into different games. I know I've been watching the I don't have a Nintendo Switch, but I've been watching the what are they called, like the Nintendo Switch releases, where they like release new games, and there's gonna be a new like Legend of Zelda game that where you can play as the girl. I sound super like naive and I've been living under a rock, but yeah. MMORPG is a great way to get sucked into gaming. Yes. Oh, you know what else has been really getting me sucked into gaming? So there's this app called Delta where you can install old games like DS or Game Boy games. And so you can get it for free if you look in the right places. Not that I'm encouraging that by any chance. But you can get those games. And yeah, I've been playing Pokemon. I got Pokemon Black, I think, which was really cool. What's the difference between Pokemon Black versus White? Like, is it still the same content? I think the Pokemon are a little bit different. Mayhaps. And I guess to bounce back Alexander Babsky's question, have you guys ever met any famous scientists before? Oh, I met met Elon Musk's son before. Not a famous scientist, but yeah. I heard there's custom Pokemon games. Ooh. Yeah, no, I know that they made like Pokemon something red. It was like Ravage Red or... My brain is saying Pokemon Rickroll Red. Where it's like a harder version of the normal Pokemon. There are version restricted Pokemon between the paired versions, so you gotta pay twice. You gotta play twice? Pay twice? Play twice? To complete the Pokédex. Ah, I see. So you have to get both of them. Like Pokemon Uranium, the guy with the weird... The closest I've got is... Oh, sheesh! Astronaut Mark Kelly? That's so cool! That's really cool. I got a book... Okay, so when I was little, I did see Neil deGrasse Tyson live, but I didn't actually get a chance to talk to him. I was just, like, in the audience of the show. There was another time where I got a book signed by Katie Mack. She is a scientist, scientific communicator. I think you guys should Google her book. What was it called? She does, like, little doodles. I think she also has like a YouTube series. She's working at the Perimeter Institute. Yeah, it's called The End of Everything by Katie Mack. Here, let me load up the... This is a really good book. It's really accessible. And it's just a really cool question. Like, what's the universe gonna end? Like, how's it going to end? It's gonna be crazy. This popular level book, yeah, it takes you through 5 universe ending possibilities. And I got it signed by her, and I actually got a chance to chat with her too, and she's just like super passionate about what she does, and I don't know, I aspire to be her. Super cool. Didn't Pokemon... Crypto, oh man, I woke up like, well, at least you're here. We're just chatting for a bit. We're going to chat, and I might head out in a bit, but yeah, this will be the second to last stream before my goodbye stream tomorrow. Actually, once we leave, you guys should be sure to save the next one, because that would not be fun if you miss that one, because that will literally be my last stream in like a month. That would be very sad. The ultimate spoiler. Yeah, entropy end. Yeah, no, there's like one there that's like the heat death. She goes through a lot of these. I really should reread this. It's a really good book. Yeah. I feel like that's just like a really fundamental question. Like, how is the universe going to end? I mean, it is the ultimate spoiler to the entire universe. Yeah. Very sad. Yeah, no, that sad face is exactly how I'm feeling too. Yeah. But it's okay. I have been also preparing like my slides to show you guys with my super duper epic announcements, along with maybe some frequently asked questions about where I'm going or how long I'm going and so forth. But yeah. In the meantime, it'll be alright. I'll still be online and everything. Whew. Alright. I think I might call it a day. Really productive day, guys. We went through that linear regression model and logistic regression today. That's crazy. It's all good. We just need to expand. Yeah, we just got to go into the other multiverse. Easy peasy. Light work. I love the contraction of the universe theory at the Oh, I love that idea too. Like, if you think about it, like, there could we could just be one of the many universes that could appear, and in each universe there could be like different laws of physics and so forth. It's just crazy to think about. Something that's just so large scale. On my on the Reddit post where I posted my astrophotography, there was this one user who was saying like that space gives them like a really deep like existential crisis, and they wrote like a really long message describing it. But I feel exactly like that. I feel like space is super cool, but at the end of the day, if you like step back and look on it, it's like, wow, we are really so small. Like, we are just a blip in the entirety of the universe. And like, it kind of gives this like idea of like nothing matters, but everything matters. Because nothing matters in that we are such a tiny part of the universe, but then everything matters because that means we can do whatever the heck we want. But it also means our life is so short that we need to make the most of it while we still have it. Understand the most that we can, explore the most that we can, explore our inner curiosity and satisfy it. Cosmic Horror, I look forward to seeing you all in the next loop cycle. X Boson, I love your username, by the way. But it's like Boson with a Z, so it gives a little bit of a Syzygy twist. Sometimes staring the night sky makes you feel lost. Yeah, no, sometimes when I look up in the night sky and I'm like, wow, that light has traveled billions of years to hit my eyeballs. Like, think about what, like, all the time that has passed on our Earth. Like, humans didn't even exist when that light was first emitted, and it's arrived here. It's just so profound. That's exactly how I feel about the Blaze Star. So this is the Blaze Star is this star in Corona Borealis that's going to explode before the end of this month. I've been trying to take pictures and look at it every night. But if you think about it, this star is dead already. It'll just take time for it to arrive to us. Oh, Z, that reminds me, I'm not sure about that subreddit rules, but you could. Yes, it's on r/virtual YouTubers. I did include my channel link, which would be super, yeah. Hopefully we can get more Orbeez. I think actually there have been a rise of Orbeez, and also a lot of people interested in like astrophotography. I should definitely do like a video or stream about that. There's always the dark forest hypo. Oh, that's dark. That's dark. No. I really like the 3 Body Problem book series. You guys should really read that. The dark forest hypothesis is like this idea that like the reason why we haven't discovered other life is because each civilization is trying to be safe and be like invisible to the others. I don't know. That's kind of scary to think about. But if you think about all the radio signals that we're sending out, that means we're already vulnerable, but who knows? We went from Carpe Diem to Carpe Meme. So deep. Well, I love surreal memes all the time, so. There was a point when no starlight was visible from Earth. Eventually, that will happen again. You exist at just the right time to see the stars. Yeah, at some point, the universe will keep on expanding. I think that's one of the endings of the universe. The universe will keep on expanding, and at a certain point, the universe will be expanding so quickly that it'll be just beyond the speed of light. And that means that we won't be able to see any stars. We wouldn't even be able to see a neighboring galaxy. Syndiquiro, good morning, gamers. Oh, well, we're actually just wrapping up right now. We're having a very deep conversation about we're having an existential crisis here. It's okay. We're all in this together. But yeah. I'll have the timestamps up for this VOD soon, and yeah. Okay, I think I'll have to call that a day. And tomorrow, I'm really sad about it being the last stream, but it'll be alright, Orbeez. It'll be alright. Everything will be alright. We are just a blip in the space-time continuum. Syndiquiro, can I ask a last question? Yeah, sure, go ahead. That'll be the last question. Alexander Ramsey, thanks. Thanks, Jeep. That's such a funny username. Just waiting on Syndiquiro's question. Let's see. Hopefully it's a little bit more happier. Oh, dang it, I'll watch the VOD. Yep. Make sure to get a lot of great pictures. Oh, for my travels. Yes, no. I have also gotten a lot of pictures from where I'm at right now. So I'll definitely have to do a live stream where I literally just go through all my photos and be like, I did this, I ate this, I love this. What's the difference between, whoa, okay, regression and back propagation? Well, as a beginner in machine learning myself, I actually don't really know the difference. Here, let me look at what back propagation is. So back propagation is an algorithm for the supervised learning of an artificial neural network using gradient descent. So wait, we use gradient descent, but this is for neural networks, given an artificial neural network and error function. So it's similar, but it seems to be for neural networks, which is a little bit different. Through error correction. So I think for regression, we can just use plain old data. But back propagation is more so for neural networks. I know that the Google course does have a neural network section, so maybe that's worth checking out as we keep going with the course. Oh, so it's where it's used. Yeah, and be sure to go through the VOD. Thanks for at least stopping by. Oh, Droid Basher. Regression is a problem type. Back propagation is optimization. Oh, whoa. Yeah, no, I'm being taught here. Backprop might be used in regression or unsupervised problems. Oh, so it's not even just limited to neural network. Yeah, no, I trust Droid more than I trust the internet right now. Because I think they're just saying that you can use that for neural networks, but maybe using regression classification or unsupervised problems. I see. Ah, I see. Yeah, no, that's a great explanation. Thanks, Droid Basher. Okay, well, that was the final question. Thank you guys so much. I'm so flunking this class. Don't worry, Crypta. These VODs will be up for you to review, and it'll be alright. Aw, thank you guys. And I'll see you guys tomorrow for the goodbye stream. I will post the YouTube live stream link right after this, so you guys can save it and set a reminder so you don't miss me going away. Sag. Nice university in your dress. Thank you. It's cosmic microwave background. Okay, guys, I think that's all for me today. Thank you so much for coming to class. I hope this was really informative. I've also been learning a lot in the process too, so I'm really glad to be sharing this experience with you all. Okay, until next time, I shall see you later. Bye. Goodbyes. Yes, good night, good afternoon, good morning. See you all tomorrow.